Hi, everybody. I'm here with a very special pioneer of sacred geometry. I'm here with the esteemed Michael R. Evans, who's been researching the flower of life and the science of curvature for the last 54 years. So I've been researching and studying his work for the last 25, 30 years. So I just want to make sure that everyone recognizes the importance of his work, because it's not just mystical, it's also has a scientific basis. And he's one of the pioneers on one of the most ancient symbols in the world, what we call the flower of life. And Michael's going to come on and give us some animations and some PowerPoints. But I just wanted this to be a chat and a conversation with a master, and we just wanted to get your work out. Yeah, so how's everything there, Michael?
Very good, thank you. I'm excited to be here, Jane.
Great, that's good. I guess I'll start with a question. I think perhaps one of the most radical things that you've done when I read your literature. Thank you for sending me your book, your PDF on the space between the balloons. It's fascinating. And what I learned from there, which I did know before, but it sort of, as I'm rereading your literature, the penny drops. And what you've been saying is that the traditional understanding of the five Platonic solids from the time of Pythagoras and all the other ancient scholars was that they only were looking at flat surfaces. They were limited by their understanding of the universe by saying that the definition of a Platonic solid was we have everything, all the vertices touch a sphere, the lines are all equal, the faces are all the same. But what they didn't account for was flexibility. So the first question would be, I want you to talk a little bit about this shape called the Trion Ray, how it actually has flexibility. So this is from the flower of life pattern. For people who don't understand where the Trion Ray come from, we're looking at the three-dimensional view of the petals. So we've got 3 of the 6 petals in the seed of life. So could you talk a little bit more why you consider the Trion Ray to be the 6th Platonic solid?
It's not a Platonic solid, it's a regular solid, because
Regular.
Plato's definition is all flat. Mine are all curved. So
Yes.
the faces are curved, mine are flexible. They're dynamic. They're
Yes.
not rigid.
Yeah.
So
And
the Trion Ray is a discovery. It follows the rules of Plato of regular solids by being all equal. Here's one that I made out of polyester.
yes, beautiful. And I love the way the light goes through that as well.
I'm glad you said that because I'm going to show you something really cool, and
Yeah.
none of this did I know before it occurred and showed me. I
Mhm.
wasn't looking for these things. They appeared all on their own.
Right.
I want to shoot a laser into.
Oh, wow. Look at the light.
Now I'm shooting the laser away from the other edge, but it's still going to the other side.
So light's traveling through the curvature.
Correct.
Right.
Which tells me that this is actual ray of light.
And that's why you
And
call
these
it the Trion Ray, because
the
it's
Trion Ray.
three-sided. It's got 2 vertices, three edges, and 3 curved faces. So according to Euler,
Euler,
the Euler
according to
rule was that the vertices minus the edges plus the faces always equals 2. And when I checked your regular solid, we've got 2 minus 3 plus 3 equals 2. So your discovery of the Trion Ray does fit with the traditional formula for what constitutes a regular solid. So I
that's
find that
correct. And it's
incredible.
taken me
Yeah.
54 years for someone to recognize it.
Yes. So
I
we're
know what it means by being ahead of your time.
yes. Wow. So we're very interested. So this changes all the science of quarks and gluons and
Absolutely.
subatomic
Gluons,
structure.
hardons. Oh,
Yeah.
it, I'm an artist. That's my background. It's not
Yeah.
science. It's not uh, physics. It's art.
Yeah.
And art preceded science and physics. And from following this and seeing how this connects everything and how this is between everything, I've been able to see the connection between me and the rest of the universe, because I'm part of this as well.
Yeah. So while we're talking about the flower of life, I've just got a few pictures for those who haven't seen your work. So we're kind of looking at something like the three-dimensional view of the flower of life, but it's not actually, because it's got pentagons and hexagons. Are you suggesting that this Trion Ray is the fundamental particle that creates all shapes? Because what we're looking at
Yes.
here is similar to like that buckyball, the soccer ball that we know with pentagons and hexagons. So are you saying that this three-dimensional petal form is the fundamental code of creation that makes everything?
Yes, I met Buckminster Fuller many years ago, and I brought him. Oh, it's in my slideshow. Let me go to that.
So Bucky was famous for the geodesic domes where he built the shells like a shell, but you're saying that this
Here's
structure
Bucky.
fills the whole sphere. This is full solid projective geometry on the inside, not just the outside. Is that
Correct. In my slideshow, you'll see that, and you'll see it in my videos as well, how it goes together. Everything is made of Trion rays. Trion rays is the elemental, and since it's a solid, it can hold a vessel. The story of the ark is like describing the Trion ray. Inside is everything that ever was. It's like when I cut the umbilical cord of my two boys,
Yes.
I saw the connection from me to them to every umbilical cord that ever was. So it's physically connected to everything that ever was for as long as there ever was anything to be. And light is the thing that connects everything else.
Yeah, I'm glad you said that, because I always thought that light had a geometry. I always thought light was something like a pyramid energy, but studying your work again, thanks to you sending me the PDF, I recognize now that light holds every frequency. Light births everything. Light is the umbilical cord of all creation.
Correct.
So
Correct.
yeah,
It's got a shape. It's a solid. So inside to be held information. And that information is pattern recognition.
right, yes.
That's the elemental thought that's contained within the Trion ray. Because when I was building all these structures, I didn't know what I was building. I didn't have a blueprint or a plan, or I was just putting tetrahedrons together. Just keep putting tetrahedrons, and then the spaces between, I found octahedrons, and then the spaces between the octahedrons, I found dodecahedrons and cubes, and then icosahedral core. So I know what I filled in the empty space.
So the reason I love your work is because we're our academy wants to get this out to children. We're an educational platform, and by getting children to say cut out the seed of life pattern like that, they cut out the petals, but they need to also cut out the negative space that you focused on, and they could start gluing them together and getting exotic ancient symbols like this curved cross. I might get you to share your screen if you want. So space between. Great title. I think that really says it all.
Well, that's how this was all invented in the first place, the space between the balloons, which we'll get into as we go along.
Okay. And the reason why it's so controversial is because
here's space clusters.
Yes.
Back in 1972, I went to all the museums in the United States. This is the Museum of Modern Art in New York. They bought 10,000 kits from me and put it in their catalog.
Fantastic.
This is 1972.
And you're calling this the geometry of light. This is basically your conclusion. This is the geometry of light.
And light is a Trion ray. This is a tetrine, a stack of tetrines which you can make from playing with the space cluster kit. There's 10 on the right, 10 tetrines. There's 20 on the left.
Is the 10 important? Because when we look at Pythagoras' tetractys, the 1 plus the 2 plus the 3 plus the 4, Pythagoras had a whole cosmology about the number 10. It's a triangle number, but here you're showing it as a volume. The tetractys as a volume of 10 tetrines.
You wouldn't be able to see the space between with straight lines. Let me say that.
Right.
That's where and then that's why nature doesn't build with straight lines. Nature builds with curves. Close up. Playboy even did an article on it in 1973.
That would have got some attention then.
It did. That's when I first started. And this is a space cluster kit. It's made out of two things, intersection and rods. Buckminster Fuller told me, look for the universal intersection. And as you said, that's what we did with the triangular pieces here. That
Yes.
was the first attempt to find the universal intersection. It's not it, because it has to be a dimensional intersection, but that's for the next person who comes along
Right.
to invent. This is an inventing machine, space clusters.
Even those red joins where you connect the sticks that curve, even they can be assembled into geometries, spherical
Oh,
geometry.
absolutely. There's a that's three faces. What about four faces? We'll get into that as we go through the here's a space launch that I did in Laguna Beach. I'd build structures all over the country and I'd tie them to balloons and I'd launch them.
Mm.
Here's an icosatrine, the core of a Mickey ball. The difference between a Mickey ball and a buckyball is a Mickey ball is described completely in the empty space, from the core all the way out to the surface. And tetrahedrons, if you put them together, they create octahedrons. And octahedrons, when you put them together, create vector equilibriums. And vector equilibriums, you keep going and it keeps birthing new geometric form.
So pretty much this negative space has created everything in the universe, really.
Correct.
As a sacred shape. Yes.
Building an icosatrine, you realize when you do it with the kit that there's forces because of the bending that make it kind of interesting. George Leonick built one, and he found it to be quite a experience. An octopus would have helped. This is a show I did at the Museum of Modern Art in Laguna Beach.
Yes.
The one on the left is a yellow icosahedron, and then it goes out, and this is all built with tetrahedrons starting, but they transform as you continue to build. They change forms.
Right. Can I ask a question about the tetrine? If we're saying that the tetrine, like the curved tetrahedron, is the fundamental building block of all atomic structure, isn't it possible that when we look at the jewel of the tetrahedron, you know, when we look inside a tetrahedron, there's a baby tetrahedron inside? Does that mean that it's not really the tetrahedron, it's actually the Trion Ray that's what creates the jewel or the fractal nature of a tetrine?
The Trion Ray is at the Planck length. It is so small. It's got at least 27 zeros after 0.1.
That's right.
It's the smallest possible. It's so small we can't conceive it. That's why things that look like they're straight lines are so small that you don't see the curves.
Right. So does the Trion Ray solve the problem of particle versus wavicle? Does that solve the problem?
Yes, it does, because they came up with particle physics. They called it particle physics because they said it was so small and so fast that we'll never be able to describe its geometry. Well, I've described the geometry. It's no longer particle physics. It's tetra physics, whatever you want to call it.
So does that mean if we're just looking at one Trion Ray and you have millions of these in a line, what we call curvature and point particle physics is described by billions and billions of these in a sequence, you could say, like the whole idea of string theory and whatever a line is really millions of these put together as a fundamental particle.
Well, look at the Mickey ball.
The Mickey ball. We need a
picture. All geometric. It's all geometric structures that are all connected, and bring that down to a billion millionth of a size.
So if the Mickey ball also contains pentagons and hexagons, can we say that this has an affinity with the DNA molecule, the helical nature
Absolutely.
of DNA?
Absolutely.
That's fantastic. This is revolutionary. Yeah.
Yes, it is. At least it was for me. And I'm not an expert, but it kept my attention for a long time. This is another show I did. The yellow is 10 tetranes, the black is 4 octatrines, and the red is an icosatrine. That
Right.
means it's going in. And in between, on the yellow one, is 4 octatrines, because the tetrahedrons, when they go together, they form something in the center as well. Everything creates everything else. Here's one of my space launches on the 4th of July, America's Revolution Day.
Is this when you contacted NASA as well, or is another separate?
Yes, I went to NASA when I came up with the kit. We knew that this was information that went further than a toy. It would show you by yourself without translation. You didn't have to translate putting things together into different languages. It was a universal way of showing geometry in a way it's never been presented before. And whenever I went to a museum to show it to them or a planetarium, they didn't hesitate and buy them. When I went to Museum of Modern Art in Martinatoma, the buyer said to me, "Don't build anything, please. I know what's going to happen. You're going to start filling my whole office with structure, and everybody in the building is going to want to come down and see it. I got too much to do. I'll take 10,000 kits."
Is that because the Mickey ball can go out to infinity? But what we're interested in, what is the central geometry of the Mickey ball? It's not. Is it the tetrine or the
changes
trion?
because you can create a Mickey ball with a icosahedral core, and you
Ah,
can create it with another type of core. I'm not sure. I haven't built them with an octahedral core.
so if it's a core of Icosa, that means those 12 vectors relate to why everyone sees base 12 as universal, like those 12 vectors of the Icosa constitute creation in a way, the 12 rays.
Yes, absolutely.
Mm-hmm.
This is I went when Fuller was at the Museum of Science and Industry. He had a show there, and it was his birthday, and I had a show going on there. I brought him this sphere to show him,
Yeah.
and we talked, and
He made some big models of that. I always thought that was Bucky's design, but this is actually your design with.
this is mine. But mine was this is his idea. 5 surrounded by 6s.
Right. I have a whole philosophy about 5 and 6. I call it Penta-hexa. And the reason why I've gravitated to your work is that 5 and 6 come up in this creation all the time. So it all fits.
You want a sphere, it's 5s and 6s.
Yeah.
So I went home and I got my space clusters out, and I had as many space clusters as you could possibly have because I made them. So I didn't have to buy them at the department store one at a time. I had boxes full. Here's a bunch of Mickey balls all going together, forming new spaces between, getting more dense.
So we got the pentagon.
This is icosahedral core.
Yes.
And the Trion Ray are spinning, turning, expanding, contracting. There's your dodecahedron is the next phase of the sphere.
So this is also the dodeca. I'm just showing people the 3D dodeca. So this Trion Ray is creating every shape known. Yes.
Correct. It's God. It's the great creator. It's the story of when they talk about God knowing everything and everything that you think you do, they're talking about this geometry because it's everywhere. It forms everything.
So that particular shape there is the soccer ball, truncated icosa. That's this shape.
Yes.
And just for those who are watching about the penta-hexa, I just wanted to show that when you slice the helical nature of DNA, you get the hexagons and the pentagon as a slice of DNA molecule. So that's why it's relevant.
I realized early on that I could not possibly figure all the things out that this does, what this means. It's something that everyone else in the world, that's why I made the toy, so people could play with it and get the idea and find and discover and invent as they went along and having fun doing it. Without any, on the back of the package of space clusters, it says, the makers of space clusters have purposely limited the images that can be made. Do your own thing, good luck, and have fun. There's always been about passing this information on to the rest of the world. If
So
light is a Trion Ray, is the elemental, smallest regular polyhedron. If light is a solid, it can hold a thought. That original elemental thought is pattern recognition. 3 dynamic equal faces, 3 dynamic edges, spins as an inside and an outside, and 2 points or vertices. It follows the rule. It's a polyhedra by definition.
right.
Now, when the further down you go into the Mickey ball, you start at the outside, which is the top, which is a C, the first one, and the distance between the points is greater than the distance between the points on the when you cut it down. When you move the points together, you get a different tone. When you move the points, that's why it's flexible. It has to be flexible, otherwise it won't happen. You'd have to be cutting and having cutoffs all the time. There's no cutoffs in this geometry. Everything is used. That's why the bending is so important.
Yeah.
The curvature is so important because it can bend.
And that allows the spin to happen. The spin gives
And
life.
it allows the spin to happen, and it allows using one length of rod instead of having to cut, because it's the core of an icosahedron, and the core and the outside skin, the distance between the points is different.
Right.
Down at the icosahedron, the points are closer together. On the edges, these points are further apart. So it's not static,
Okay.
flexible.
So it's a dynamic geometry.
And the
Yes.
Trion Ray will also twist. This Trion Ray on both sides. This is where it all started. A fellow by the name of Bob Auerbach worked at the Continental Can Company in Chicago. And he was a package designer. And a package designer has to make displays that are 2-dimensional, but unfold to be 3-dimensional. So he went to Fuller, and Fuller told him, gave him the idea of coming up with curves. So he went home and started and drew out all the different possibilities using the cusp, the flower of life. The 3 is basically the flower of life, one element. Then there's a 4, and there's a 5, and there's a 6, 7, 8, and 9. And they all have one thing in common, the cusp, the Trion Ray.
Yes.
That's the thread. It weaves a multi-dimensional loom of life itself. Here's some of the structures that I built with paper. We call them the flats.
So we can call this the fabric of creation, really. This is the fabric of creation.
It is. It's showing it in different dimensions. The one on the second one, the rounded triangle, is the same as the one next to it, except the spin is different. The Trion Ray is spinning, so it's straight on one side and curved on the other.
And you call that one the tetrex, is that right? The one on the left, you
Tetrex.
call the tetrine, that's concave.
Tetron is the middle one.
No, tetrex is the curve, the convex.
Tetrex is the curve, outside curve.
And then you combine the two somehow?
They're the same.
They're the same.
It's just a position of the Trion Ray.
So the third one, you call it the tetron, is it? Because it has
Right,
convex.
tetron is
concave.
the one at rest.
Okay.
The next one's an octatron. Or an octatrine, I'm sorry.
Octatrine. So you've come up with a whole new jargon, a whole new description of elements.
When I was at the toy show in New York back in the 70s, a fellow by the name of Edmund, who had a company called Edmund Scientific. It was a magazine that sold science equipment like all the things that surplus science stuff. And he came to my booth and he saw all these structures hanging up. And he said, "What do you call those? I've never seen that structure before, that geometry." And I realized at that time that as I was finding these structures, because I didn't know they were there either, but I was finding them, I had to name them.
Mm.
So we'll get to that slide.
So this is truly a journey of discovering, which is the best way to learn.
This is an inventing machine. Space Clusters was an inventing machine. For everybody that played with it, they discovered it and they had the thrill of going through the eye of the needle.
Mm.
This is Trion Ray making a tetrahedron or tetron.
Yeah.
This is 4 tetrons making an octatron in the middle.
Mm.
These are tetraks making an octatron in the middle. We talked about a triangle within a tetrahedron.
I can see these as architectures, like as amazing new designs in architecture,
Architecture,
biotecture.
electronics. These are ways of making connections in ways that won't get hot because there's space between to keep it cool. If you want to build a submarine that'll go to the bottom of the ocean, if you flex, if the thing is built from metal, or could be anything, that flexes, you're not going to get a break. It's going to flex. Here's your flower of life, which all of a sudden, what I've done is I took the flower of life off the 2-dimensional plane and brought it into 3 dimensions.
Right.
It followed the path that it led. Luckily, I didn't know enough about anything to know that it wasn't there. Ignorance is bliss. Mickey ball on the left, Mickey ball on the right, on top of the flower of life. So I took that 2-dimensional.
And that's why this work is important, because for the last 30 years since Drunvalo Melchizedek was teaching about the flower of life, no one ever thought to consider its multidimensionality. And I think that's where you've really taken this to the next octave of science and learning. And that's why everyone is so excited about this new content. It's always been there. You've just opened up a flower, in a sense. You've opened up the flower of
It was
life.
information to change things. And we knew it would take time for it to grow, but it's finally coming into its own, the information. It's been there since the original flower of life in Abydos in Egypt.
So Abydos would be the oldest known record of the flower of life. Like that's probably what, 3,000 to 4,000 years ago, right? That's quite a lot.
Right. Well, this is the next
You've been
step.
very patient. You've obviously, I mean, you've been doing this for 54 years now. Your main lesson would have been waiting for your time, or the patience involved in just doing your work and just loving what you're doing, being passionate, discovering. But now the world's listening. They're really excited about this.
I'd like to see space clusters reintroduced into this generation. The kids that bought the toy back in 74 are now 45, 55, 65.
And they're all engineers now. They're all engineers, hopefully.
So I knew that if we made it into a toy, that was the easiest way to get the information out, because I went to NASA and NASA said it wasn't invented here. It's a great idea, but
or maybe
we've already got plans. We're not changing them.
What if they're using your idea? Maybe it was such a brilliant idea, they just running.
They will. They could have put it.
This would be new propulsion systems, like what Terrence Howard's talking about. The linchpin is a new propulsion system. But anyway, keep going.
Here's the flower of life coming alive, blooming. It all fits together.
The seed of life, fruit of life.
There's a tetrine and an octatrine, and it sort of resembles the flowers behind it.
We've got the tree of life and the lotus of life. Everyone's playing with this concept of the flower of life notion?
Here, I'm doing it with the flats.
Right.
This is computer generated, showing that what these geometric forms can make, because they're electromagnetic fields that are created. And since it's all flexible, as it forms, it shows it on the right that's what's possible and still be connected at the points. This is my desk here where I'm sitting now.
The universe. Wow. So this works on all scales. When we look at this work, this body of work, we're looking at the infinitely small and the infinitely large. So this works on all levels.
That's what it is. The infinitely small, the infinitely large are the same.
I love that. Yes. As above, so below.
Exactly. These are ones that I made out of polyester to shoot light through them. Lenses.
Right.
Most lenses are two-dimensional. These lenses are multi-dimensional.
Beautiful.
The one on the right is octatrine is created when you put four tetrons together. The
Right.
space between is created an octatrine. So that gives birth, the geometry gives birth to the next phase. It's alive. Everything is alive. This is Lawrence Livermore's crystal that they shoot lasers through.
Right.
Well, this is what you get if you shot lasers through this. This is a 10 stack of tetrahedrons.
Are these real crystals? Like they're not just
No, there's something. I made these.
Okay.
I made molds, and I poured polyester, and I worked hours and hours and days and weeks polishing.
Beautiful.
And I do the Essene prayers when I would do polishing.
Because every thought is captured into the geometry. So what's important with all this new technology is the consciousness of the inventor. That's why we're not against technology. We love good technology, but what people are missing is that the consciousness of the inventor is imbued into the creation. And that's why this Trion Ray is star-seeded by someone of your caliber, that your thoughts, your intentions are pure. And that's what's really important.
Just trying to pass the information, what I found, to the rest of the world. This is images when shooting light through that geometric optics. These are just some of the creations of light going through. See the dragon on the left and the bird on the right?
Yeah, I can see that. Yes. Very
That came from shooting light through my crystals. The one on the left is the vertical trions in the middle of a Mickey ball. That's with everything else stripped away.
Right. Are they the 12 vectors? Are they the 12 vectors in the middle?
Yes.
Yeah.
Correct. This just shows you, I split it in 5 different cuts. And this is what makes the Mickey ball. 20 sets of 10 tetrahedrons going into the middle, which is an icosahedron. And then you get the Mickey ball and everything's connected.
Right.
This is slicing it again. This shows you the different positions of the 6 regular solids in time and space. The cube is a cubitrine, a cubex, a cubitron. An octatron, octatrine, octatrex, octatron. Dodecatron, dodecatrine, dodecatrex, dodecatron. The different positions, the different ways the same thing looks at a different momentarily.
I'm particularly interested in the bottom one, the icosatron. instead of the seed of life with 6 petals, we've got 5 petals. And I love the way the 5 and the 6 permeates all this geometry. It's beautiful.
The 6 is created by the rest. That's what makes 6 different. This is another set of space clusters. Instead of using rods, we used color stays. This is a vector equilibrium.
Mm.
The red is the vector equilibrium, the blue is octahedron. So 4 octahedrons create 1 vector equilibrium.
Love it. That's great, because this Buckminster Fuller's whole work was about this vector equilibrium. So this embraces all of Bucky's work as well, with the 12
Oh, yes, it does.
radial.
Absolutely. Absolutely. And it takes it further.
What I love about this cube octahedron, the buckyball thing, is that it's the only known shape in the universe where every radial, if that's a matchstick in the middle there, the radius, the inside length is the same as the outside length. It's the only shape where the inside vector is equal to the edge length. There's no other shape that does it. That's why it's so balanced. Yeah. And
me holding a stack. Me
right.
in my studio in Laguna Beach shooting light and lasers through my structures.
Thank you for that. That's a true journey on the science of curvature. Beautiful. I had another question. I'm particularly interested. My life's research in sacred geometry led me to a thing called a true value of pi. As I researched pi 3.141, I realized that they were measuring pi based on straight lines, and that they never really accommodated for what we call the area under the curve, the area under the circle. So I believe that the pi has a different value. Does that fit in? Do we have the pi value a bit deficient? It should be based on the golden ratio. Do you have any view about how pi could be corrected, or that there could be another?
I am very ignorant. I only know what I know, and I never studied anything else. I used to buy science books for the pictures. If it had no pictures, I didn't buy them. Because I couldn't. I was trying to find things that I was making that would be described in the physics books. But I remember I'm an artist. I'm not a mathematician or a physicist. I don't know all the work of everybody that's done what they've done. I know about a few. I know about Letterman, a few of them, but I'm a pretty ignorant guy.
Your work with the curvature suggests that for 2,000 years, we've been trying to measure the area under the curve, that which we call pi, but they've been using like millions and billions of sort of very narrow rectangles. It's all based on straight lines. So there must be some fundamental error with pi. But my main research is that when you look at the square in the circle and all these other geometries, the golden ratio permeates all geometries. So my theory is that there is a true value of pi based on the golden ratio, but your work kind of touches on that when we start looking at the fundamentals of curved space.
It's a tool and a new way of looking at things. You're looking at another dimension. And I stopped there because I knew it was infinite in the applications in construction and building and physics. If you built a computer chip like the Mickey ball,
Yes,
you'd be able to get an awful lot of information in there faster, quicker, without overheating.
right. Is that
No
because
end
of
of
the Trion Ray? If we believe in sacred geometry that shape stores memory, then the fundamental geometry that stores shape would be the Trion Ray, because it keeps
Can you find
configuring
something
itself.
smaller that encompasses space
Yeah.
and holds the information?
I just wanted to come to a conclusion, but I just thought, well, I've got another 5 minutes. I wanted to get your thought on the work. I wanted to give an honor to the work of Victor Schauberger. So you're aware of Victor Schauberger's work?
No, sir.
Well, he solved a problem in Austria about more than 100 years ago. They were trying to, when they were chopping big trees up in the mountains, there was a log jam. So he created this kind of spiral flume down the mountain so that all the logs could flow down to the river and to the port. So the Austrian government loved him, and he was a water scientist. But my friend here in this picture, my friend here who lives 3 hours from me, his name's Callum Coates. So Callum Coates translated his work from the German into English. And what Victor Schauberger discovered was the thing called the tonal tower. So this is a wooden model that was made in Austria by Victor, and Callum made it here. But you know that thing in the Bible called Gabriel's horn?
Yes.
Which was about a curved trumpet, like a long Tibetan horn. And this is it here again. So we've got all the, it's basically the hyperbolic curve. There's a formula that Callum and Victor talked about called n, a number n times its reciprocal 1 on n. So 6 times 1 on 6 equals 1. So Victor Schauberger and Callum Coates had a whole philosophy that fits in with your space curvature, that n times 1 on n equals 1, which is all, when you talk about the 1, we're talking about unity consciousness. So this is another diagram. So he spent his whole life talking about this formula, n times 1 on n equals 1. And it's a very cosmic formula. But again, not many people know about Victor Schauberger's work based on Kepler, the P-chiasis, Pythagoras, and Kepler systems. So I just thought if you knew about this formula, y equals 1 on x, so 6 times 1 on 6 equals 1. When you plot it, you get this curve that goes to infinity. But when you rotate this formula, y equals 1 on x, you get the hyperbolic curve. And this is a whole cosmic philosophy of infinite circles. So every circle here, if this is 1, this is half of that, this is a third of that, a quarter. So these are all the reciprocals, but it goes to infinity. It looks like a witch's hat. So I was just curious that if you knew about the tonal tower, there's another whole cosmology that kind of piggybacks on what you're doing about curved space, and it goes to infinity. It connects the infinitely large, infinite small. But we can talk about that another time. But do you have any comment about what you just saw with those pictures?
Well, I have one desire, to make the other 7 kits of space clusters. And if anyone out there wants to take this further, I'm here, California.
Well, we're going to help you find the sponsors. One reason we're doing this is that we're connected in this educational design, and we
Well, that's what it should be. If you're going to teach mathematics or geometry in school, play with this toy.
Yes.
Creative Playthings took a whole mess of structure of pieces in one of their classes, and they just put them into a box. And the kids would come out and they'd have to figure out what to do. And the only thing you had to learn how to do was take the rod and stick it in the intersection. Right. If you keep doing that, you'll have a lot of fun.
Yeah, and children learn through what we call discovery. And I think you're the emblem of a master who spent his whole life just discovering nuggets of information. So I just wanted to honor you for your work. We want to get this out to as many people. So we might do a follow-up video later on when we get some response.
I've got more structures here that I didn't pull out, so.
That's okay. Well, we'll make that a part 2. And just wanted to honor you for your time and for your wisdom. And that.
Well, I thank you very much for recognizing what I've been doing for so long.
Thank you.
With space and time. So thank you.
We'll come and visit them. So we'll take you up on.
Got it. I'm in San Diego County in Fallbrook, California. Thank you so much. I really appreciate it.
You're welcome. Bye.
Okay.
Hello.
Bye.
Hi, Michael.
Where's my magazine?
I need help as well.